Okay, let's finish up chapter 6. We're going to talk about proportions, ratios, and proportional reasoning. Starting off with the definition, a ratio. A ratio is denoted by these three different setups. There's three different ways to write a ratio, and they all mean the same thing depending on the context of the question. That kind of makes proportions and ratios a little bit hard for people to understand. So a ratio is where A and B is an element of a rational number, and it is the comparison of two quantities, the quantities of A compared to B. Here's kind of a little example so that you understand what I mean. A ratio of 1 to 3 for sugar to flour. And let me stop for a minute. Notice that this is the order in which the ratio is. That means the sugar is 1 and the flour is 3. These are always in the order of which the description gives you. Okay. That means that the amount of sugar is 1/3 of the amount of flour, right? So if it takes 3 cups of flour to 1 cup of sugar, then sugar is 1/3 less. It also means that it's 3 times the flour than there is sugar, as I just said. We can also switch the ratio around if we'd like, and we could call it 3 to 1, but we also have to switch the description around. Now it is flour to sugar. So we haven't changed anything here. Pardon me. We haven't changed anything here on the veracity and of the relationship between flour and sugar. We just changed the way we wrote it around. I also want you to note that a ratio doesn't actually give you the exact quantities of like flour or sugar. It just describes the relative size of each ingredient. So if we were talking about cups of sugar, it would be 1 cup of sugar to 3 cups of flour. Goodness, I'm so sorry. I don't want to have to restart. I already had a coughing fit a second ago. Hold on 1 second. We could also say 1 teaspoon of sugar to 3 teaspoons of flour. The units, as long as the units are same and the ratio is the same. Goodness. Then the relationship maintains. Sorry. The next definition is a proportion. And a proportion is denoted very specifically in this kind of ratio notation, but can be written as a fraction. And a lot of times we are given it in a proportion form and we change it to a fraction because we know how to do operations on fractions. So if I have a recipe that calls for 2 cups of sugar to 3 cups of flour, if I wanted to write the proportion, it would be 2 to 3. If I wanted to write it as a fraction, it would be 2/3. Now, the proportion is a good way to describe the relationship between the 2 cups of flour and the 3 cups of flour and the 2 cups of sugar, because what if you wanted to double the recipe or triple the recipe or half the recipe, right? That would still, those proportions between the two, the relationship of the quantities between the two would have to maintain the same, so it'd be easy to figure that out. Brings us to a theorem, and this theorem says for A, B, C, and D, all elements of the rational numbers where B is not equal to 0 and D is not equal to 0, then A over B equal to C over D is defined as a proportion if and only if A times D is equal to B times C. Now, we wouldn't really use this theorem very much unless we were trying to prove something at this point. At this point, I'm just demonstrating that this is the theorem and there is equality here. Also, to be noted, the way that we say this expression here, A over B equals C over D, is A is to B as C is to D. Okay, that indicates that we're dealing with a proportion and not just two fractions equal to each other. All right, let's solve some proportions here. our first example says Allie and Ben type at the same speed. Allie started typing first, and when she had 8 pages typed, Ben had done 4. When Ben was done with 10 pages, how many had Allie finished? Sorry, phone. Okay, so first things first, and the steps to solving these proportion equations always start the same. You want to write what the given proportion is. That's the very direct proportion that they give you. And here it is. She had typed 8 pages and Ben had typed 4. Now, another thing I want to tell you about proportions is this is really a great practice to note what is on each level of the proportion. So in this case here, I have 8 to 4. So 8 was for Allie and the 4 was for Ben, right? And so I want to just kind of keep this together. Now the next thing that we're asked to do is to set up the proportion equation. And here we're using the additive method. And so to set up the proportion equation, that means we're going to add some number to both sides. I don't know why I drew 2 equal signs. Let me not draw 2. That was kind of silly. Let me draw 1 equal sign. And our new denominator for Ben is 10 pages. And we don't know what the denominator for Allie is. And what we're going to do here is solve it using the additive method. And the additive method says you want to determine the number of units that need to be added up to get to the number that we're trying to get to. Well, if we started at 4 pages, we need to get to 10. We had to add up 6. What we do to the denominator, we have to do to the numerator. And so we can see that 8 plus 6 is how many pages. And so our final proportion here is 14 over 10. And so now we can say Allie typed 14 pages. Okay? So let's look at another example. This example we're going to do in 2 different methods. Let me draw a little line down here so we can see. Okay, so the question is, Carl can type 8 pages for every 4 pages Dan can type. If Dan typed 12 pages, how many had Carl typed? For both of these, we're going to start the exact same way as we did our last example. The first thing we do is we find that given proportion, that map to how we're going to solve this here. And what the map is 8 pages for every 4 pages. And we have Carl and we have Dan. Carl types 8 pages for every 4 pages Dan types. So there's our given proportion. Now we need to set up the proportion equation, and the proportion equation is if Dan types 12 pages, how many has Carl typed? So we get a full equation that is 8 over 4 equals x, because we don't know how many that is, and we use x in math for unknown quantities, over 12. Okay, so here's our proportion equation, and now we're asked to solve this equation, and we're going to isolate the x by multiplying both sides by the denominator of the x, or the inverse of 1/12. We're using additive or multiplicative inverses here. We're multiplying by 12 over 1. Okay? And when we do the math there, we have 4 over 3, so we wind up with x is equal to 24 after you do the math. Okay? All right. So let's look at the cross multiplication method. And I want to warn you, and I think I might warn you again, but just in case, because I don't remember if I did, I want to warn you that the cross multiplication method can only be used to solve proportions. It can only be used when it is literally a fraction equal to a fraction, okay? So the first two steps are exactly the same. So I'm going to just write our equation down here. 8 over 4 is equal to x over 12. Now, just as it suggests, the cross multiplication means that we multiply on the diagonals. Okay? So our equation becomes 4 times x equals 8 times 12. Solving this, we have 4x is equal to 8 times 12 is 96. And when we divide both sides by 4 here, or multiply both sides by 1/4, we get x is equal to 24. Now this is without a doubt the preferred method, and the method that will be used almost exclusively once you get to this point in your teaching. Okay. All right, let's hop on here to the next. So it's very, very important to pay attention to the units of each element in the proportions. Like, got to pay attention to what the units are so that you set everything up correctly. So in proportions, we compare the like things to the like things. So here's an example. A turtle travels 5 inches in 10 seconds. How many feet does it travel in 50 seconds? Now check this out. We're talking seconds to seconds, which is not a problem. Seconds to seconds, so that is like to like, but this is asking us to go inches to feet. And inches to feet is not like to like. Okay, now we can solve this equation because we know that 12 inches equals 1 foot, and we'll be able to get the final answer. But I want to make the point that this is not the perfect proportion here, and we're going to have to do an additional step. So let's solve it. Okay, so let's set up our given proportion, which is 5 over 10, and I'm going to put my notes here. This is 5 inches in seconds, and that's going to equal, we don't know how many inches in 50 seconds, and I'm just putting these because I want to make sure that you see these units very, very clearly. Okay. All right, and now at this point we can cross multiply, which is awesome, and we're going to say 10 times x is 10x equals 5 times 50. So we have 10x is equal to 250. Divide by 10. X is equal to 25 inches. We have to come up here though and see that the question asks for how many feet. So now we must convert feet to inch, or convert inches to feet. So how do I want to say this? How did I do that? My brain just went, and how did I do this in my notes? Yeah. Okay. So we are going to convert inches to feet by dividing the answer by 12 because there are 12 inches in a foot, as I said above there. Okay, so let's do it real quick. I've got 25. 12 divides into 25 2 times with 1 left over. So our answer is 2 1/12 feet in 50 seconds. That's a pretty fast moving turtle, honestly. Less than a minute, 2 feet. Okay. Okay, let me see if this works. I made a mistake in my earlier iteration, and fingers crossed this will work. Okay, so we're going to look at scaling, and to do the scaling, first we're going to find the least common denominator of our two ratios. Let's get our ratios that we have here. Our first ratio is 12 tickets for $15. And our second ratio is 20 tickets for $23. And I'm going to write them this way. 15 over 12 and 23 over 20. And we need to find our least common denominator of the number of tickets. Okay, so this is money over ticket, money over ticket. Okay, so we need to find the LCD of 12 and 20. And you can do the math yourself. The LCD of 12 and 20 is 60. I'll save you the hassle of me showing how to do that. Okay, and so now what we need to do is we need to rewrite each of our ratios in terms of 60. So for our 12 tickets at $15, we're going to say 60 tickets is equal to X dollars, and we're going to cross multiply and solve this equation. We have 12 times X is equal to 15 times 60. When you do the math here, we get X is equal to 75. Now this other one here, this is going to be equal to X over 60. And when we finish this guy, we're going to have 20 times X is equal to 23 times 60. And when we do the math there, we get X is equal to 69. Okay, so what is the better deal? Paying more or paying less? Looks like the 20 tickets at 23 is the best deal. Okay, let's look at it using the unit rate idea, because this actually requires us to do a lot of extra work, in my opinion. And if we want to look at it in the unit rate, what we do is we find the cost of one ticket for both of the ratios. Okay, so again, we'll start off with our 15 divided by 12, and I'm just literally going to do the long division here. So 12 goes into 15 one time. 12, subtract 3, bring down the 0, put the decimal point here too. We haven't learned how to do this in this class yet, but I mean, you could have done the fraction, could have done it another way. This is just how I went after it. 24 minus, and then we're left with 6. Bring down another 0, that's 60, so $1.25. $1.25 each. Okay, and then we'll do the same thing here. Of course, we know the outcome, but let's just go ahead and struggle through it. So that's going to be 20 goes into 23 one time, 20, get the 3, put in our decimal point, bring down the 0, 20 goes to 31 time, bring down the 20, we've got 10, bring down another 0, 15, so this was $1.15 each. So we can also see that 20 for 23 is best. Okay. So let's go to the next one. If I can get my stuff to work. Oh. Okay. So this is what I was afraid of. I had to re-record this slide, and now it will not let me go any further. So I'm going to stop. I'm going to keep this, and we're going to pick up with a part 2. Because I've already recorded this twice this afternoon. Okay, thanks.